What do you think will happen when we heat magnesium ribbon in the presence of steam? Check it out.
For this experiment, we'll be using magnesium ribbon, a test tube, stopper, water, some cotton, and a Bunsen burner. So the first step is to take your magnesium ribbon and unwind about, maybe 12 inches to 15 inches worth, and then start wrapping it around a smaller test tube. And this way you get a nice coil of magnesium ribbon. If the test tube is smaller than the one that you're putting in, then you can kind of put the coil into the second test tube where the reaction will take place. Now, after you have a coil, then take your cotton, put it in the bottom of the test tube where the reaction will take place, and try to cram the cotton down into the bottom. And then you're going to saturate your cotton with water. And that way, when you start heating it up, the water inside the cotton will start to evaporate. And as that steam moves over the magnesium ribbon, the magnesium, which is highly reactive, will displace hydrogen gas from the steam and create magnesium oxide in a reduction oxidation process where the magnesium is losing electrons, it's being oxidized, and the hydrogen gas is being reduced as it gains electrons. And so just take a dropper and add some water to your cotton so the cotton is fully saturated. And then you'll take your coil of magnesium ribbon and you're going to kind of inch that down toward the middle of the test tube. So you'll have your Bunsen burner on the cotton so that starts to release steam, and then you can move your Bunsen burner back and forth over the magnesium ribbon. Place your rubber stopper over the end, and then you're ready to start to heat that cotton. So the minute that you start seeing steam coming out the end, then you can start heating up your magnesium ribbon and just kind of move your Bunsen burner back and forth from the ribbon to the magnesium to the cotton again until you eventually get the magnesium to start to glow. Once it starts to glow, keep heat on the cotton so you have a steady stream of steam that's moving over that hot magnesium, and your reaction will keep going. Now, if you can't seem to get the magnesium lit, then use a torch on the magnesium ribbon. And you can see me using the torch right here just to really activate that magnesium. Just needs a little more activation energy. Once it starts to glow, then you can just keep the Bunsen burner on the cotton, and that steady stream will displace hydrogen gas that you can ignite into a torch on the end. Pretty cool reaction. You can definitely see the redox process, but you can also see the displacement of hydrogen gas by igniting the torch.
Here's the balanced equation for this amazing single displacement redox reaction. We start with the reactants magnesium and water in the form of steam. We have 1 mole of magnesium, Mg, and 1 mole of water in the form of steam, H2O. When those are combined and activation is added from the blowtorch, we get the products magnesium oxide and hydrogen gas. So we have 1 mole of magnesium oxide, that's the MgO, and 1 mole of the diatomic molecule of hydrogen gas, H2. This is a reduction oxidation reaction and a single displacement reaction as hydrogen gas is being displaced, but also as magnesium is being oxidized, it's losing electrons, while hydrogen gas is being reduced as the hydrogen gains electrons in this amazing reaction. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.